Kia ora Year 9. This video is going to go through the first page of the revision booklet for algebraic expressions. So just in case you're watching this from another class, this video is not for the JAF practice test. There are separate videos on that I've done in the last couple of years. So this one is just going to look at questions 1 to 19 on the sheet that's the little 4-page booklet, right? So the first page is Unistructural, then there are a couple of pages of relational and then extended abstract. I'll do those videos later. So in this video, guys, I'm going to go quite slowly. It's probably going to be, I'd say 12 to 15 minutes, and I'm going to try and get through all 19 questions. So the first 3 questions that we've got here are all about like terms. And they're about like terms because I'm asked to add different terms together, right? So here I've got B plus another B, another B, another B, another B, and another B. So because those are all the same variable, I can add them together, right? So I've got 1, 2, 3, 4, 5, 6 of them. So that gives me 6B. And we keep moving through these 3 questions with the same idea of like terms, right? So in the next one, we've got an A and an A. They're the same. And then we've got a B, and a B, and they're the same variable. So when we put those together, we get 2A plus 3B. Now remember, in algebra, we don't write the times sign. So this means 2 lots of A. So 2 lots of A is 2 times A, and this is 3 lots of B. So we can think about it like that, but we have this convention thing that we do where we don't write that times sign. So the correct answer for this one is to write it as 2A plus 3B. Now, moving on to number 3, the first thing we do again is we see that we've got something plus something, take away something, and then plus something. So we're looking at the idea of like terms again. Here we've got 7 lots of M, and then we've got take away 2 lots of M. So they're going to go together. And we've got 4 lots of X and 3 more lots of X. So altogether we get 5M, 7 take away 2, plus 7X. Then the idea that we're working with changes, right? So these questions are all about plus or minus, so we're looking at like terms. In this one, we start to look at multiplication. And we know when we're working with numbers that if I have 4 times 4 times 4, that's equal to 4 to the power of 3, right? So the little 3 means to the power of. And it works in exactly the same logical way when I'm dealing with a variable. So here I've got P times P times P times P. So that will be P to the power of 4. Okay, so that's the first 4 questions done. Moving on to the next ones, we've got 3 more questions that are about multiplication, and then we've got our first one that's about division. So in question number 5, we've got 4y times y. I can think of that as 4 times y times y. And we know that the y times the y is y squared. And so this one, the answer will be 4y squared, right? This x in here is a times sign, right? Because it's written like that. If we mean x a variable, it's the weird curly one written like that. And that, I think, sometimes can really confuse students in Year 9. So sometimes we try not to use x too much. But it's good for you to get used to it. So in this question here, if you're watching this and just wondering if you have to write all of this out, you don't, right? But I'm doing that to show you what's going on, right? Because I want you to understand that 4y means 4 times y, right? So that's why I did it like that. There, I'll do it like that again. So 4 times y, right? And so we put the number, the coefficient first, and we write it as 4y squared. In number 6, we've got 4, and then we're timesing by p times p times p. And lastly, we're timesing by a. Right, now, the order we do multiplication in doesn't matter. So when we write this, we're going to write, I'm going to write this the slow way first, right? So this is the same as 4 times a times p times p times p. So this line of working, you don't have to show that, but that's my brain trying to sort out what I'm doing. So we can write that as 4AP cubed, right? It's P cubed because I'm timesing P by itself 3 times. So that's that one done. Now with this next one here, I'm going to go straight away to writing the answer, right? So it's going to be 3 times R times R times P times P times P. So the final answer here will be 3 R squared P cubed. We don't need the times signs. And it's totally fine to write it as 3 P cubed R squared. If you tried to write it like this, that would look really weird, right? So we have this very strong convention in algebra that when we've got what we call a coefficient, we always put it first, right? So that one would get a correct answer, and so would that one. So the order of the letters doesn't matter. The number has to come out the front. Okay, so now we're going to move on to division, which is definitely a little step up. But if you remember from when we worked with number, whenever I have a number divided by itself, that equals 1, right? So 17 divided by 17 equals 1. So if I said to you, simplify for me, 17 times 3 times 4 divided by 17 times 7, what we can do there is we can divide the numerator and the denominator by the common factor. And the common factor is 17. So we're left with just 3 times 4, which is 12, over 7. And that's the idea that works in algebra as well. Okay, so in here, we've got y times y times y times y. And down here, we've got y times y. So we've got some common factors. And what I can do here is I can simplify those out. So that this y times the y gives me 1, and this y divided by the y, sorry, not times, this y divided by y gives me 1. So that leaves me with y squared. Right, so let's just have a look at that one again. Here we've got y times y times y times y. So this is a common factor in the numerator and the denominator. Because it's a common factor, we can simplify fraction. We're left with just the y times the y. We know that that's y squared. Now I'm going to show you another way that we could have written that, because we don't have to want to keep writing this out the long way all the time. In fact, we're going to see it in question 9. So in this one here, we've got a times a times a times a times a times a. And in the denominator, we've got a times a times a. So we can simplify this fraction as follows. And you'll see that we're left with a to the power of 3. Now, if you're in my class and you're working on foundation skills, we've looked at a faster way to do that. Right, so this top line here, I'll pull this one out here, this is equal to a to the power of 6. And in the denominator, this is equal to a to the power of 3. And we saw here that the answer we get left with is a cubed, right? And hopefully you can notice that in here, we've got a to the power of 6, we've got a to the power of 3. So the a's are going to end up being kind of heavier when they're in the numerator, right? Because it's a times itself 6 times. So my final answer is going to be a to the power of 6 take away 3, right? Because that's what I've done when I've simplified all of those. So one more example of that, if I had a to the power of 8 here and a to the power of 5 here, my final answer here would be a to the power of 3. We can look at these powers when we've got the same base and we can find the difference, right? Take one away from the other. Okay, we're up to 9 minutes already, so this is probably going to go the full 15. In these next ones, we have to work with fractions again. So 26x divided by 2 is equal to 13x, right? And that's because 26 divided by 2 is 13. So if I wanted to do that more slowly, sorry guys, I've got a little bit of a funny throat, but it's not COVID. Okay, so 26 divided by 2 simplifies to give me 13, right? And that's 13 divided by 1. But we don't need to worry about writing divided by 1. We just write 13x. Same idea in the next one. 24 divided by 8 is 3. So we've got 3a for this one. In the next one, we can write that out as 5 times x squared divided by 15. Well, 5 over 15 simplifies to give me 1/3, and I end up with x squared divided by 3, right? Remember that we don't write the 1 in the 1x squared, right? That can just magically disappear. There, it's gone. Okay, so that's number 12. So with the division ones, what you have to remember is that all the stuff we learned on simplifying fractions is still important. Okay, so we've got lots of simplifying fractions. Now, the next batch of skills are about expanding and factorizing. And there's a separate video on how to do both of those. If you need to find it, send me an email. So we've got 4 times b is 4b plus 4 times 1 gives me 4. Right, so when I'm expanding, I take whatever's here and I times it by what's inside here. Expand 5 times x plus y will be 5x plus 5y. Now factorizing is going back the other way. So we look at each term and we find the highest common factor. Highest common factor here is going to be 5. 5 watts will give me 5x, 5 times x. 5 watts will give me 10, 5 times 2. So that's that one done. Next one, factorize 6x plus 12. The highest common factor is 6. So it's going to be 6 times x plus 6 times 2. So that's that one now factorized. So expanding and factorizing is something that takes quite a bit of practice. Well worth doing some Dr. Frost skills practice on those. I'll have the key skills list on Google Classroom this morning. The last 3 that we're going to do are something that we did very, very early in the topic. So this is about substitution. So we're asked to evaluate, and that means figure out the value of, right? So you can see in there the word value in there. So we're going to take 5x minus 2y, and we're going to say, let's make x 3, and let's make y 2. This is one of the most useful real-life skills that algebra gives us because it lets us work with different formulae for things like finding the temperature, doing lots of conversions, and finding lengths of stuff, right? So this is a very hands-on practical skill, even though it doesn't look like it just yet. So in here, the x comes off and the 3 goes on, right? So 5x minus 2y is going to be 5 times 3 minus 2 times 2, right? The 2 is what happened to the y, right? And the 3 is what the x became. And then we work it out using BEDMAS. So that one is 15 take away 4, which is 11. Okay, next one, 3a minus 2b. So 3a minus 2b is equal to 3 times 4 minus 2 times 3, which is 12 minus 6, which equals 6. Now, just also look when I'm doing that working that I'm showing the person reading it that I've substituted my values in. Okay, and that's good because that means we can check back what we've done. Last question, question 19, 6p minus 4k is equal to 6 times 3 minus 4 times 2. 6 3s are 18, minus 8 gives me 10. So there you go, guys. I've done that hopefully slowly enough that everyone can follow. If you've still got questions with that, then best to go back to the foundation skills videos. There are 3 of those that go with the foundation booklet. Let me know if you've got any problems. And if you find a mistake in here, the first person to find the mistake, if there is one, will get some chips from the canteen.